let's work a concrete example of this one before we actually prove it for the general case. Now these curly braces indicate the fractional part of a rational number. Okay, so let's take a look. So 1 over 5/6 would be 6/5, right? All right, now if you want to evaluate this, the fractional part of a number between 0 and 1 is just a number, right? So this is going to be equal to 5 over 6. And then the fractional part of 6/5 is of course 1/5. All right, and just by appearance, this can't be equal to 1, but let's go ahead and verify here. What is this? This is equal to 26 over 30, maybe? Is that right, folks? Or no, 31 maybe? Is that 31? I believe so. Yeah, 5 times 5 is 25, plus 6 is 31 over 30. So you see this is not equal to 1, right? Now, of course, that doesn't make a proof, but it at least gets you into the mode of what's going on here and how it's unlikely that this can happen if you're talking about rational solutions. Now, so this is the definition of the fractional part, and you can check it right here. Like if you put 6/5 right here, it would be 6/5 minus the floor of 6/5, which is 1. 6/5 minus 1 is the 1/5 that you see right here. So this is just a formal definition. This is called curly braces. Now, what we're going to do right here, we're going to suppose that we can always reduce the fraction. Another way of saying that is that the positive integers a and b are co-prime. And you can write it like this. They have no common factors. Okay, nothing in common. 5 over 6 is an example of a numerator and a denominator that are co-prime. Okay, so this is what this says. There exists a rational number such that this is equal to 1. And we're going to show the impossibility of that. And most of this is just slogging through the definition, a little bit of algebra. Okay. Now, so here we go. The fractional part of a over b plus the fractional part of 1 over ab is, again, you take the right here, the 1 over a over b is just b over a, so you can see where all of this came from. Okay, now right here we have a over b plus b over a, which is equal to this piece right here. Okay, again, y'all, a over b plus b over a, common denominator, you're going to get a squared plus b squared all over ab. Now remember that a and b are relatively prime. They're relatively prime, they're co-prime. So this circled object right here is not an integer, okay? I'll just put not a member of the natural numbers, okay? Or the positive integers, right? And that's clear simply because, say, just think of a squared being over ab. Well, the a's would cancel, and that would say that b would have to divide a. And similarly for over here, okay? But since they're co-prime, that can't happen, and this can't be an integer. But this, by definition over here, this is the floor of a over b plus the floor of b over a. This is guaranteed to be a natural number. Or, a non-negative integer, maybe, something like that, okay? But anyway, you have something that's not a natural number minus a natural number that's not equal to 1, right? So you see it can't happen. Cannot happen. So this is not equal to 1, QED. We have demonstrated. All right, so let me know what you thought. If I glossed over anything a little bit too much, I'm assuming everybody knows this definition right here, and I didn't spend too much time on that. But it turns out there's an infinite number of irrational solutions, and I can talk to you about that in another video. So anyway, I hope you enjoyed this one. Let me know if there's anything I can do to make it clearer. I'm getting to the point where I'm not showing quite as much work, leaving that to the viewers. Otherwise it gets too kludgy. I could have done more here to convince you, I guess, that this wasn't a natural number, but hopefully it's very clear that since A and B don't share any common factors, there's no way this object here, in a similar way of saying it is that think of B squared over AB. You see the B's cancel and you have B over A, and B over A cannot be an integer, just like A over B cannot be an integer, okay? There's no way this can be a natural number. And again, work through the algebra if that doesn't make any sense. But anyway, that's it. Thanks for viewing.